here we're looking at right angle triangles. We use trigonometry to calculate the length of a missing side or the size of an angle within a right angled triangle. So we calculate so that could be any of the three sides or any of these two angles here. We use ratios of the lengths of the different sides of the different sides of the triangle. Firstly, let's label up the triangle. So if we pick this to be our angle X, then we label our sides up with different names. So this side here would be called the opposite, because it is opposite the angle. This side here would be called the adjacent, because it's next to the angle. And finally, our diagonal is called the hypotenuse. So each time we decide that we're going to do a question involving trigonometry, we need to identify where our angle in question is, and then we label up our triangle with these three sides. There are three main trig ratios. The word trig is just a shortened version of trigonometry. And our three ratios are tangent, which we shorten to tan, cosine, which we shorten to cos, and sine, which we shorten to sine. We just drop the E there. We use these three ratios to be able to work out those missing sides or the missing angles on a right angled triangle. So let's do some examples. Example 1. To calculate the length of a missing side and that's going to be our first example, so that is here. Okay, so the question is asking us to calculate y, that is a side on a right angled triangle. You'll notice that we are given the angle 40 degrees. So in this case, when we're trying to find a missing side, we have to know at least one other side and an angle, the size of the angle. So the first thing we're going to do here is we are going to label up our triangle, and then we will decide which of our ratios we are going to use. So if this is our angle, 40 degrees, our side opposite must be called the opposite. Our side next to the angle is our adjacent. And finally, our diagonal is the hypotenuse. Right, so we have the three ratios. We now need to look and see which one we would use. So here are our three trigonometry formulas, and we will decide which one to use. So we have tan x This is the tangent equal to the opposite over the adjacent. We have cos x equal to the adjacent over the hypotenuse. And we've got sine x equal to the opposite over the hypotenuse. These can be shortened to O over A over H, and O over H. So O stands for opposite, A for adjacent, and H for hypotenuse. So we would look at our triangle that we are given in our question and decide which of these three trig functions would we use. So we'll quickly just have a look. What we've got in our question is we have information about our angle. So that is this one here. We've been given our adjacent, and we've been asked to find information about the opposite. So we know our opposite, and we know our adjacent. Well, we don't actually know our opposite, but that's what we're trying to calculate. So which one has the two ticks? It is the tan. So we will be using our tan function. Now there is another way that people tend to remember this, and you might have heard of it before. That would be so ca tua. So that's just a shortened version of this information here. The SOH comes from the sine with the opposite over the hypotenuse. The cos, the ca, comes from the cos with the adjacent over the hypotenuse. And the TOA comes from the tan with the opposite over the adjacent. So you might want to remember this little bit down here to remind you of which trig function you should be using for what sides you have been given in the calculation. So in this case we decided that we would be using tan. We'll do the working over on the next page. I'm just going to redraw the right angle triangle. So that was the information that we needed, and we were trying to find y, and we said that we needed to use tan. So tan x is equal to O over A. This was our O, and this was our A. So we will substitute our information that we have in the question into the formula now. So it's tan. Now our angle is the part that goes with the tan here. So this is 40. So it's the tan of 40 is equal to, we don't know what the opposite is yet, but we've got a letter, so we can replace that with y. And then A is 12.5. So that part there is substitution. Now we need to rearrange to get y by itself. So I'm dividing y by 12.5. So if I want to move that up to the other side of the equation, I would do the opposite. So I would multiply by 12.5. So 12.5 times tan 40 is equal to y. And when you put that into the calculator, you end up with y is equal to 10.5 centimetres if you round that to one decimal place. Right, we will do a second question. This time we will look at when we have a missing angle. We're still using the three trig functions, so the sine, the cos and the tan. So you might want to use your SOHCAHTOA to work out which of those three formulas you will use. So example 2. So to calculate the size of a missing angle. And again, we've got a triangle. So this time we've got x. 4 centimetres for one side and 10.8 centimetres there. And they're asking us to calculate the angle x. Right, so let's label up our sides. So here is our angle x. So this side over here must be our opposite. The side next to the angle is the adjacent. And finally, our diagonal is the hypotenuse. So now we need to decide which sides have we got as part of this calculation. Well, we obviously have the opposite because they have given us a value for that. And we have the hypotenuse because they have given us a value for that as well. So it's the opposite and the hypotenuse. So if you want to write out your SOHCAHTOA, we can tick what we have. We have the opposite and we have the hypotenuse. So therefore, we're going to use a sine. So first of all, write your formula. Sine x is equal to the opposite over the hypotenuse. And then we sub in our values that we have. So we don't have x this time, so we've still got sine x equal to 4 over 10.8. Now if we work out what that is, we're going to end up with a decimal, 0.370. Now we have an extra step this time in the calculator because what we have is sine x equal to 0.370, but we want x is equal to. So to take the opposite of sine, we do something called the inverse sine. So it's x is equal to sine to the minus 1 of 0.370. And I'll just write that over here. So sine to the minus 1 means inverse sine. And on your calculator, you would press the shift button followed by the sine button, and that would bring up sine to the minus 1 on the calculator, and then you would type in 0.370. Once you press equals, you should get 21.74 degrees. And remember your units. In the last one we were dealing with centimetres because it was the length of a side. This one here we're dealing with degrees because it's the size of an angle. And that concludes our basic trigonometry. We can use basic trigonometry in right angled triangles only, and we must be trying to find a missing side or a missing angle.